problem based on parallel and consecutive reactions. This is a question related to parallel path reactions in which a compound A is dissociating into two parallel first order paths at certain temperature. Given A gives 2B and A gives C, where K1 is equals to K2. They have mentioned K1 value is equals to K2, and that is given as 6.93 into 10 power minus 3 minute inverse. Now the reaction started with 1 mole of pure A. So the value initially is 1 mole in 1 liter container with initial pressure of 2 atmosphere. What is the pressure developed in the container after 50 minutes from the start of the experiment? Now what is this time related to the experimental conditions we have to find? Is there any relation of this time to the experimental conditions? Let us find out that by taking a simple logic. If I am taking T half is equals to 0.693 by K total, this is for the overall overall rate constant with respect to A. So T half of A is equals to 0.693 by overall rate constant or K total, which can be given as 0.693 by K total is K1 plus K2, which is equals to 0.693 by 2 into 6.93 into 10 power minus 3, which is equals to 100 by 2, that is 50 minutes. Now you can see the time 50 minutes is related to half life of A. Now we have got the first point. There is the relation of 50 minutes with respect to A is it is the half life period of A. Now let us solve this particular one taking a simple logic. A is giving you 2B and giving you C. This is our equation. We know K1 and K2 are equal, but they are the respective rate constants for each path. Now A is started initially with 2 atmosphere. After some time t, this becomes Pi minus x, which is equals to 2 minus x. But we know the time t is equals to 50 minutes is nothing but exactly the t half. At t half, what will happen? The 2 minus x will be equals to 1 because it is exactly decomposed to a x value will be equals to 1. So this is x value. We got the x value, how much is decomposed from A, as half-life period indicates half of the composition gets decomposed in the course of the reaction. Initially you have 2 atmosphere. Now you will be left out with 1 atmosphere, where 1 atmosphere will be involved in the decomposed form. Now the x we got, how much amount is decomposed, is 1 atmosphere is been in the formation of decomposed form. Now how much B is going to be formed? Let us understand this with a simple formula base. Now the amount of B formed, so amount of B formed, or you can say the partial pressure of B, the partial pressure of B is equals to the fraction of B formed into stoichiometric coefficient of B, stoichiometric coefficient of B, fraction of B into stoichiometric coefficient of B into the x, which is coming from A, which can be taken as, what is fraction of B is K1 by K1 plus K2 is fraction of B into stoichiometric coefficient of B is 2 into x, which is equals to K1 by K1 plus K2 becomes K1 by 2 K1 into 2 into x value is 1. K1 gets cancelled. Since we know K1 and K2 are equal, K1 plus K2 can be written as 2K1. So 1 by 2, 2 and 2 gets cancelled. So this becomes 1 atmosphere. Now partial pressure of C, if you calculate, partial pressure of C is equals to fraction of C into stoichiometric coefficient of C into x, which is equals to K2 by K1 plus K2 into stoichiometric coefficient 1 into 1. This is equals to K2 by 2K2 into 1. So this is equals to 0.5 atmosphere. Now let us see what is the total pressure. Total pressure is equals to pressure of A plus pressure of B plus pressure of C. pressure of A left plus pressure of B and pressure of C formed. Left atmosphere is 1, pressure of B formed is 1, pressure of C formed is 0.5, which ends to 2.5 atmosphere. So the answer we get is 2.5 atmosphere, and that is in the option D.